Let's think of another integral that may not seem so obvious that we should use integration by parts. We got the arctan of x here. How should we be able to use integration by parts here? There's not even two factors. You got just 4 and arctan. So let's have our u be arctan. But then what will our dv be? We can just have our dv be 4 dx. So what happens when we look at this? We have our du, which is our 1 over 1 plus x squared dx, and our v is 4x. And then when we use the formula, this is actually going to look a lot nicer. We have the same sort of thing where we have to evaluate v times u, which is the 4x arctan x evaluated from 1 to 0. And you got the subtracting of 4 times x over 1 plus x squared. You may think, well, that's not a whole lot better. But what you're going to have to see is this bottom value here is going to be very easy to evaluate using just regular u substitution. So I know this one is multiple parts, but integration by parts takes this very difficult integral to deal with, arctan, makes it something familiar that we can use our u substitution to be able to solve. So let's use sub. U equals 1 plus x squared. Du is just 2x dx. So as we go about evaluating here, we will get pi minus 2 natural log of u evaluated from 1 to 2, which is equal to pi minus 2 natural log of 2, which is pi minus natural log of 4. And that will be our final answer. So you may be asking yourself, where did this pi minus 2 natural log of u 1 to 2 come from to get this nice formula? Well, the pi value here just comes from the uv, right? If you plug 1 into arctan of x, you get pi over 4. So you get 4 divided by times pi over 4, which is just pi. Then arctan of 0, that's just 0. So that pi value, that's what this is bringing about. And this remaining, the minus 2 natural log of u evaluated from 1 to 2, is what this integral turns out to be. So let's think about this a little more. We have this value. We have a u up here is 1 plus x squared, and du is 2x dx. Well, we got an x here and a dx. We also have a minus 4. So let's bring 2 in, and so that way we have minus 2 integral of du. And this bottom, 1 plus x squared, that's just u, integral of u. And then what are our bounds? Well, when we plug 0 into 1 plus x squared, we get 1. And when we plug 1 into 1 plus x squared, we get 2. So this is the integral that this turns out to be with our u sub. This is just the integral of 1 over u, which we all know is just the natural log of u. And so we're able to get this value here. The rest is just simple evaluations.